Hello students, welcome back to another video of MATHIPHY. In today's video, we will do paper 2, which is a multiple choice paper. It's course code 0625, October-November 2024, variant 2. Question number 1 says, two forces with magnitude F1 and F2 acts on an object with right angle to each other. What is the magnitude of the resultant force? So F1 and F2 are the forces which are acting on an object at 90 degrees to each other. We have to get the magnitude of the resultant force, which is basically the hypotenuse. To count this hypotenuse, we can use Pythagoras theorem, according to which hypotenuse is equals to square root of base square plus perpendicular square. So in our case, A and B are F1 and F2. So resultant would be square root F1 square plus F2 square, which is option number A. Question number 2 says, a boy takes 30 minutes to cycle distance of 8 km and then further distance of 2 km in 15 minutes. What is the average speed? To calculate average speed, the formula is total distance over total time. The total distance is 2 km and 8 km, that means it is 10. Now the total time for 8 km he takes 30 minutes, but we need the time in hours. So what will I do? I'll convert 30 minutes into hours by dividing 30 by 60. So it would be 0.5 hours for 30 minutes, and we will do the same for 15 minutes as well. 15 divided by 60 is 0.25. So the total time taken by the boy is 0.5 plus 0.25, and this would be equals to 13.3 as a final answer. That means D is the correct option. Question number 3 says, a small light bulb is dropped from the top of the building. Which graph shows the speed of the ball changes with time? So there is a ball which is going to fall on the ground in this direction. When the ball is falling, the air in the environment will try to resist the motion of the ball and it will apply force in the opposite direction. This force is the force of resistance. Due to this resistive force, the velocity of the ball will start decreasing, and there will come a point when the downward force of the ball would be equals to the upward resistive force, and they will balance each other and the ball will attain a constant or a terminal speed. So C is the correct option, because you see, firstly the velocity is decreasing with the time, and then finally there comes a point when upward force is equals to downward force and the body achieve a terminal speed. So C is the correct option. Question number 4 says, which statement about gravitational field is not correct? It is gravitational attraction per unit mass and it is represented by G. First option is it changes the mass of the object. This is not correct because mass is not changed by anything. It remains same everywhere. So this is not correct. This can be our option. It is equivalent to acceleration of free falling object. Yes, its value is 9.8 and it is equivalent to it. It is measured in Newton per kg. Yes, we measure in Newton per kg. Next says its magnitude is different on other planets on our solar system. Yes, because on Moon the value of G is 1/6 of its value on Earth. So it's true. Question number 5 says three liquids PQR have different densities and do not mix. The liquids are placed in measuring cylinder and are allowed to settle. A small box is dropped into measuring cylinder and it comes to rest as shown. The block is over here. It sinks through R and Q but doesn't sink through P. The thing we need to know is object with greater density sinks. So if the object sinks through R and Q, that means object has greater density than R and Q, but it doesn't sink through P, that means object has lesser density than P. Out of these options, A says that the block has equal density as Q. No, it sinks, so it must have greater density. B says the block has greater density than P. No, because it's not sinking, so it must have lesser density than B. This is not correct. C says it has greater density than R. Yes, it sinks through R, so it must has greater density than R. So this is the correct option. Question number 6 says the diagram shows a uniform beam pivoted at the center. F1 and F2 are acting on it. Which row is correct? So we'll figure out which force is clockwise and which is anti-clockwise. We'll rotate the force towards the pivot. This is an anti-clockwise motion opposite to the motion of clock. So F1 is anti-clockwise. Rotating F2 towards the pivot, this is the direction of clock, so it is a clockwise motion. Now we will calculate the moment of each. Moment is force multiplied by perpendicular distance of force from pivot. So the perpendicular distance of this F1 from this pivot is D3. That means the moment is F1 times D3. Now for the other force, the force is F2 and the distance, perpendicular distance from the pivot is D4. So the moment would be F2 times D4. Now we will see which row is correct. Anti-clockwise moment is F1 times D3. So it's F1 times D3. We have two options. And clockwise moment is F2 times D4. So that means D is the correct option. Question number 7 says, which expression can be used to determine impulse? Impulse is basically force multiplied by the time period for which the force acts. So A is the correct option. We can also write it as force times delta T. Question number 8 says, which row shows the process by which energy in the sun is released, the process by which it is transferred to earth, and the way in which it is stored in earth once it reaches the earth? Okay, so what is the process in which sun produces energy? Sun produces energy by the process of fusion, because hydrogen and hydrogen fuse into each other and they produce a large amount of energy. So the process is basically fusion. So fusion, we have three options. I am underlining these. Now, by which process this energy is transferred to earth? From sun to earth, there is space and there is no air. We have vacuum. So we can't transfer energy by the process of conduction and convection because both need molecules to travel. So energy is transferred in form of radiations, electromagnetic radiations that do not require any medium to travel. So radiation is the option. Okay, by the method in which the energy is stored in earth, energy is stored in form of biofuels. We know coal and fossil fuels store energy from the sun. So the option D is correct, fusion, radiation and biofuel. Question number 9 says an object has the mass of 20 kg. It is taken up to stairs at height 4 meter. What is the increase in the gravitational potential energy? Gravitational potential energy can be calculated by the formula mgh. M is mass and h is height. So mass of the object is 20 kilogram. Gravitational acceleration is 9.8 near the earth and height is 4 meter. So multiplying these together, I'll get the value 784 joules, and when I round it off, it would be 780 joules. So D is the correct option. Question number 10 says an electrician uses a lifting machine as shown. The lifting machine takes 4.5 seconds to lift the electrician at vertically height of 3.2 meter. The mass of the electrician is 72 kg. The energy for lifting the machine is supplied by 2 kilowatt motor. What is the efficiency of the lifting machine? So there is a person who need to lift at the height of 3.2 by a lifting machine. This lifting machine work on 2 kilowatt power to lift the person to that height. That means this 2 kilowatt is the input power of the machine. We have to get the efficiency. The formula for efficiency or percentage efficiency is power output over power input times 100%. But if we need efficiency only, we don't have to multiply it by 100%. We know the power input, but we have to get the power output. For power output, we can use the formula that power is energy supplied in unit time. And energy that we are supplying is a kind of gravitational potential energy because we are lifting it to certain height. So instead of energy, I can write gravitational potential energy in unit time. Gravitational potential energy has the formula mgh, so I can replace it by that as well. So it would be mgh over t. Now I'll plug in the values and I'll get the power output. The mass of the person is 72. I'll plug 72 in place of mass. G is 9.8. The height to that the person lift is 3.2. And the time the machine take is given by the question, which is 4.5. Doing all the calculations, the power output would be 501.76 watt. Now I'll put it over here to get the efficiency. Output power is 501.76. Input power was 2000 watts. Because it's 2 kilowatts, I can convert it into 2000 watt multiplied by 100%. Now dividing these two values together, it would be 0.25 multiplied by 100%. Again, we don't supposed to calculate the percentage efficiency, so I'll not multiply it. B is the final answer. Question number 11 says, some altimeter use the change in air pressure to measure height. If the pressure is 100 kilopascal at the sea level on a particular day, what will be the pressure at the top of a 30-meter hill? The density of the air is 1.3 kilogram per meter cube. So we are at the sea level and the pressure is 100 kilopascal, and we are supposed to move at the top of the hill, which is 80-meter high. What would be the pressure at the top of the hill? To get this pressure, firstly we need to calculate the change in pressure when we move from sea level to that height. To get the change in pressure, we will use the formula pressure is equals to rho gh. Rho is density. I'll put the value of density of air, which is 1.3. G is 9.8 near Earth, and height is 830 in our case. So change in pressure would be 10,574. Going from sea level to the height 830 meter, we experience the change in pressure to be 10,574. This is the change in pressure. Now what is the pressure at the height 830? To get this pressure, I'll subtract the sea level pressure from the change in pressure. The pressure at height 830 would be 89425.8 Pascal, and when you round it off it would be 89 kilopascal, and the option C is correct, 89 kilopascal. Question number 12 says, water exists in three states, solid, liquid and gas. In which state the motion of water particles is only vibration? In solid, the particles are not allowed to move freely, they only vibrate, and ice is a solid. So option number C is the correct option. Question number 13 says, a cube has the sides 3 meter long and the cube contain a gas at pressure 800 Newton per meter. A second cube has side 4 meter long and the cube contains the same mass of the gas as in the first cube at same temperature. What is the pressure of the gas in the second cube? Question is saying that the temperature is held constant and pressure volume are changing, so we can use Boyle's law. P1 V1 is equals to P2 V2. We are supposed to get the pressure in the second cube. That means we are supposed to get P2. So I'll rearrange the equation with respect to P2. It would be P1 V1 over V2. We have to calculate V1 V2, the volumes of first and second cube. For V1, it's a cube, so its volume would be L cube. And the value of L is 2 meter for the first cube, so it would be 2 cube. And 2 cube is equals to 8. That means the volume of first cube is 8 meter cube. Doing the same for the next cube, its volume would be 4 cube because its lengths are 4 meter. V2 is 4 cube. 4 cube is 64. That means volume of second cube is 64 meter cube. Now I'll put the values in the formula. P1 is 8000, V1 is 8, and V2 is 64. I'll do the calculations in the calculator and it will turn out to be 1000 Newton per meter square. That means option A is correct. Question number 14 says, which row gives the correct name for each change of state shown? Gas to liquid, liquid to gas, and solid to gas. In this chart, I have named all the state changes. Gas to liquid is known as condensation. So it can be this or this. From liquid to solid, this process is known as freezing or solidification. So it could be these two. For solid to liquid, this process is known as melting. That means this option or this option. In option B, we have all three shaded, so option B is the correct answer. Question number 15 says, in an experiment to measure specific heat capacity, a block of aluminium is heated and its rise in temperature is measured. The initial energy gained by the block is delta E, the mass is m, and the rise in temperature is delta T. Which expression is for specific heat capacity of aluminium? Option C is the correct expression for specific heat. Question number 16 says, which statement about the transfer of thermal energy is correct? First is, all metal conduct thermal energy equally well. No, all metal have different conduction properties, so this is wrong. Question number B says, convection occur in solid and liquid. No, convection occur in gases and liquid because the particles in solid are tightly packed, they can only vibrate. C says convection occur in liquids because hot liquid is more denser than cold liquid. No, it is opposite of this. Part number D says the radiation that transfer thermal energy are the type of electromagnetic radiation. Yes, I have just told you that from sun to earth, energy is transferred by radiations, and these radiations are of electromagnetic radiation because they do not require any medium to travel because there is vacuum between sun and earth. Yes, this is correct option. Question number 17 says, what is the number of wavefronts per second that passes a fixed point? Number of waves or wavefronts passing through any point in a second is defined by frequency. So it is the frequency of the wave. 18 says, an earthquake under the ocean can be produce a dangerous water wave called tsunami. This table shows the data for a tsunami. We have ocean depth, velocity, and wavelength. A student suggests the three conclusions about the data. The deeper the ocean, the faster the wave. The longer the wavelength, the faster the wave. The faster the wave, the higher the frequency. Which conclusions are correct? The question is discussing frequency, so let me just draw an other column for frequency here. You know, frequency is inversely proportional to wavelength. So if the wavelength is higher, the frequency would be less. And if the wavelength is less, that means the frequency would be more. Now we'll see the options one by one. The deeper the ocean, the faster the wave. Yes, when the ocean is deeper, the velocity of the wave is more. And when the ocean is less deeper, the velocity of the wave is less. We can see it from the data, so first option is correct. The longer the wavelength, the faster the wave. Okay, when the wavelength is long, the wave has the higher velocity, and when the wavelength is short, it has less velocity. That means option 2 is also correct. The faster the wave, the higher the frequency. No, because when the wave is faster, the frequency is less, and when the wave is slower, the frequency is more. So C option is not correct. Only 1 and 2 are correct. Question number 19 says the diagram shows what happens to wavefront at sea when they enter a harbor. What causes the change in the shape of the wavefronts? Wavefronts are entering a gap, and after it the waves are spreading out, and the spreading of the waves from any gap is known as diffraction. Question number 20 says a ray of light passes from air into the glass. What is the angle of incidence and angle of reflection? We measure angle of incidence and diffraction from the normal, but this angle is given from the surface of the glass, which is not correct. We have to measure this angle from the normal. This surface and this normal are making 90 degree. To get that smaller angle, I will subtract 90 from 50. That means it would be 40 degree. So angle of incidence is 40 degree. Angle of refraction is already correct. It is measured from normal. That means the option number A is correct. Angle of incidence is 40 and diffraction is 25. Question number 21 says an object is placed in front of a converging lens. The lens has the focal length f. The lens produces a real enlarged image of the object. What is the position of the object? When we see image formation by a convex lens produces a real and an enlarged image when it is placed between f and 2f. F is the focal point and 2f is the twice of focal point. So, in this diagram, this position is 2f and this position is f. That means B is the position between f and 2f at which the image would be real and enlarged. Question number 22 says, what is the speed of electromagnetic wave in vacuum? In vacuum, all electromagnetic waves has same speed, which is 3 into 10 raised to power 8 meter per second. But our question is asking the value in kilometer. So we have to convert it into kilometer by dividing it by 1000. When we divide this value by 1000, we will get this value, and this is C option. Question number 23 says, the starter in an athletics race fires the starting pistol. There is a wall 60 meters from the starter. Take the speed of the sound as 330 meters per second. This person is going to shoot a gun and the waves of the sound will travel back into the wall and then again come to that person, and this person will hear the echo of that sound. How long after firing the pistol does the person hear an echo? Okay, for echo we have the formula 2 times distance divided by the velocity of the sound. So it would be 2 times 60, which is the distance between person and the wall, divided by the velocity of the sound, which is 330. Doing the calculation, I'll get 0.36 seconds. Question number 24 says the diagram shows the magnetic field around a conductor which is carrying current, where the strength is greatest. For a current carrying conductor, the magnetic field would be greatest near the wire, that means at position A. Question number 25 says a positive ion in a vacuum moves at steady speed in a straight line. There is potential difference between two plates P and Q so that they are oppositely charged. When the positive ion enters the region between plates P and Q, it changes its direction as shown. The diagram shows the view. Okay, so there is a positive ion which is traveling towards these two plates P and Q, and these plates P and Q are charged and they are oppositely charged. Now, if the positive charge is moving towards the plate P, that means plate P is negatively charged, so plate Q would be positively charged. So these are the charges. Which diagram shows the direction of electric field between the two plates? It can't be A because it's not tilted. It can't be B. It is C because the field lines travel from positive to negative charge and they are parallel and straight lines. Question number 26 says, in a circuit shown, the voltmeter read 2 volt, a charge of 5 coulomb passes through the resistor in a certain time. How much energy is supplied to the resistor in this time? The voltage across the resistor is 2 and the 5 coulomb of charge is going to pass from this resistor. How much energy is supplied by these 5 coulomb of charges to the resistor? Potential difference is defined as energy supplied by a unit or 1 coulomb charge by passing through any component. So energy would be voltage multiplied by charge. Now I'll put the values. Voltage is 2 across the resistor and charge is 5. That means energy supplied would be 10 joules, which is option number C. Question number 27 says, which diagram shows the current voltage graph for a filament lamp? A filament lamp is a device that do not follow Ohm's law, which is voltage is directly proportional to current. It doesn't follow this rule. Let's suppose it's a filament lamp and current is passing through it. When current passes through a filament lamp, the filament lamp start heating up. That means the temperature of the lamp start getting increased. Resistance is directly proportional to temperature. If the temperature is rising, that means resistance will also rise. If resistance of any component is higher, it will block the flow of the current. That means current would be reduced. So which option out of these is relatable? Option number A. Why? Because see, when voltage is increasing, firstly, the current was increasing along with the voltage, but after some particular time, the value of current starting to reduce because the resistance increased that blocked the flow of the current. Question number 28 says the diagram shows an electric circuit. Which statement is correct? This is a positive terminal and this is a negative terminal. The current will start moving from positive terminal and this emitter A is going to read the full current supplied by the battery. Now, after this, the current will reach this junction, after which the current is going to be split into A2 and A3 emitter. So A2 and A3 are not going to read the full current. So emitter A is reading the highest current out of these three because it is reading the full current. 29 says the diagram shows the arrangement of resistor in series and parallel. R1 is series with R2 and R3 which are parallel. Which equation is used to calculate the combined resistance of the resistor? As you know, R2 and R3 are in parallel, so their combined resistance can be calculated by the formula R2 times R3 divided by R2 plus R3. After getting this combined resistance of two parallel resistors, the third one, R1, is connected in series with the both. So this would get added simply with the combined resistance. So it would be plus R1. That means option number B is correct. An electrical engineer has made a pair of component P and Q. The resistance of P decreases when temperature rises and resistance of Q increases when temperature rises. The total resistance of P and Q in series remains constant when temperature changes. The two components are connected in series with the power supply. Which statement is correct? According to question, there are two components P and Q connected in series with the power supply V. For first component, when the temperature increases, the resistance of the component also increases and the name of this component is Q. Other component is component P. When the temperature increases, resistance of component P decreases. But the point to note is the combined resistance or the total resistance of component P and Q are always constant. That means when you add both, they will give you a constant value. Next thing that we need to know is that in series combination, the total voltage is split across the components that we have. And the splitting depends upon the resistance. If the resistance is greater, the component will get more proportion of total voltage. If resistance is less, the component will get less proportion of total voltage. But if the combined resistance is being same, we can say that whatever is the division between Q and P, when we add the both voltages received by Q and P, this will give us the constant value because the total resistance is being constant. To conclude, we can say whatever voltage QP receives, their total voltage would always be same as supplied by the battery. So sum of potential difference across P and potential difference across Q does not change with temperature. Question number 31 says the diagram shows a wire XY moving upward in magnetic field. A current is induced in the wire. The current carrying wire XY experiences a force because of its interaction with magnetic field. Which row gives the direction of induced current and the direction of force experienced by the wire XY? The question is asking for the direction of the current induced in the wire when it is moving upward in a magnetic field. For induced current, we use Fleming's right hand rule. Our forefinger would be in direction of magnetic field, which is towards right. Our thumb would be upward in the direction of force, and the direction of induced current we will see is from X to Y. So we have got the direction of induced current, it is from X to Y. Now we will calculate the direction of the force experienced by the wire XY. We are not talking about this upward force. We are talking about the force that is discussed by Lenz's law. Lenz says that when there is a certain force which is inducing a current in a wire, there would be an opposite force generated that will try to stop the production of that current and will try to oppose the induced current. And this force is in opposite direction of the force that we are applying. That means this force is downward. So motion of current is from X to Y and force is downward. Question number 32 says the diagram 1 shows a magnet being pushed into a coil that is connected to a center zero sensitive voltmeter. In diagram 1, the south pole is moving towards the coil and the coil is showing a deflection in this direction. In diagram 2, the magnet is stationary. That means the flux is not changing through the coil, and when flux doesn't change, there is no EMF induced or a current produced, so it will show zero deflection. In diagram 3, the south pole is moving away from the coil, so it will show the opposite deflection that it was showing in diagram 1. That means in this direction, opposite to diagram number 1. That means our option number C is correct, which is showing the deflection that we have mentioned. Question number 33 says, what is the purpose of brushes and split ring commutator in a DC motor? For example, this is the diagram of a coil of a DC motor. Here we have the coil. These rounds are the rings and these dark points are carbon brushes. What does these carbon brushes do? You know, DC motor is being supplied by a direct current which do not change its direction. After half cycle of the coil, the direction of the current need to reverse so that the direction of forces would reverse on the coil and coil will complete its rotation. This work is done by these carbon brushes. These changes the terminals to reverse the direction of the current so that the coil will keep rotating itself. Question number 34 says the diagram shows beta particles being directed between poles of the magnet. In which direction will the particles be deflected? Beta particles are electrons, or we can say negatively charged particles. So if negatively charged particles are moving towards right, the direction of current would be opposite to the direction of negative charge. That means current will travel towards left. So this is the direction of current. We are supposed to detect the direction of force in presence of current and magnetic field. For this we will use Fleming's left hand rule. The direction of magnetic field is downward from north to south, so our forefinger would be downward. The direction of current is towards left, that means our middle finger would be towards left. Our thumb is representing the direction of force, which is outward towards us or out of the page. B option. Question number 35 says an alpha particle and beta particle have same kinetic energy. Why does the alpha particle have larger ionization effect than beta particles as they pass through air? They both have same kinetic energy, and kinetic energy depends upon two things, mass and velocity. So if we talk about alpha particles are heavy and they have greater mass. That means to have same kinetic energy as beta particles, they would have a lesser speed to maintain the kinetic energy constant, and beta particles have lesser mass. To make the kinetic energy same, they would have a greater velocity. Talking about the charge, alpha particle have the greater charge and beta particle has the lesser charge because they have less mass. Now, which of the option is correct? Alpha particles have large charge. Yes, they have. But large velocity? No, they have small velocity because they have heavy mass. Talking about B, alpha particles have large charge and smaller velocity. Yes, the both options are correct. So B can be the correct option. Talking about option C, alpha particles have smaller charge. No, it's wrong. And again, it's saying alpha particles have smaller charge. No. So B is the correct option. Question number 36 says a student is carrying out experiment to measure radiations from radioactive. He uses a radiation detector and record the total count in 5-minute interval. He does this 3 times with the source present and 3 times with the source absent. Here are his results. He is going to take 3 readings with the radioactive source present and 3 readings with the radioactive source absent. Source absent means the radioactive material is not there, these are only background radiations. And these are background radiations plus radioactive source radiations. If we want to get the radiations only from the source material, we will make a third column and we will subtract background radiations from the data which is containing background and source radiations both. It is 43, 73 minus 28 is 45, 69 minus 22 is 47. Now this is the count of radiations from the source material only, but we need the average count, so we will add all the values together and we will divide it by the number of values, which is 3. That means the average that we have got is 45 counts per 5 minutes, because the data that we have got is calculating counts per 5 minutes. But our question is demanding us for the counts per minute. To get the count per minute, I will divide 45 by 5, which would be 9 counts per minute. So our answer is option number B, 9 counts per minute. Question number 37 says, the count rate measured near a radioactive source dropped from 542 counts per minute to 94 counts per minute in 12 hours. The background count remained constant at 30 counts per minute. What is the half-life of the source? So a source has 542 counts per minute, including 30 counts per minute of background radiations as well. So to get the source count only, I'll subtract the background count. 542 minus 30 is 512 counts per minute. That means source has 512 counts per minute, and this is being reduced to 94 counts per minute in 12 hours. How many half-lives will it take? In first half-life, 512 is reduced to half, that means 256. In next half-life, 256 would be reduced to half, that means it would be 128. Again, in third half-life, it would be reduced to 64 counts per minute. Now 64 when added by 30 counts of background radiation will give us 94 counts. 64 plus 30 is 94 counts per minute. That means from 542 to 94 counts, it took 3 half-lives. 3 half-lives are equal to 12 hours, because the question is saying it took 12 hours for this process to occur. What is 1 half-life? From 3 half-lives, if we want to get 1 half-life, I'll divide 12 hours by 3. 12 divided by 3 would be 4. That means answer number C is correct, 4 hours. Question number 38 says, what happens when the protostar becomes a stable star? In a protostar, we have a fusion process going on in which hydrogen and hydrogen are combining and producing a very large amount of energy, and the temperature inside is very high. Due to this high temperature, there is an outward force generated. When this outward force is balanced by inward gravitational force of the protostar becomes balanced. That means option number B is correct, which is saying the inward force due to gravity is balanced by outward force due to high temperature. Question number 39 gives us a table. In this, we have mass compared with Earth, average density, and gravitational field at surface of different planets. Which statement about these planets is correct? First is saying mass compared to Earth increases, the average density increases. If I see when mass compared to Earth is increasing, and if I compare the density as well, the density is decreasing. That means first option is not correct. Second is saying mass compared to Earth increases, the gravitational field strength increases. Let me see again. If mass compared to Earth is increasing, yes, gravitational strength is increasing. Comparing it for the Mercury as well, the mass is decreasing, gravitational field is decreasing. For Uranus, mass is increasing and gravitational strength is increasing. That means option B is correct. Question number 40 says, which quantity is an estimate age of universe? Age of universe can be calculated by inverse of Hubble constant. Thanks for watching the video. If it was helpful, please hit the like button and subscribe my channel.